time I see someone using something that I've made, I get a little rush. I think, I made that and someone using it, and that is the coolest thing in the world. That is the best part of making things. The hard part is that, well, making things is actually pretty hard. When you make something, there's a million complex problems to solve. And to overcome these issues, it can require a laser-like focus on a specific sub-problem at hand. This focus is what lets you get past the problems and actually create something that's worthwhile. But that focus can also be a bad thing. It's easy to get so caught up in working on the specific individual issue that you forget to step back and think about the experience of actually interacting with the thing that you're building. Sometimes there's so much technical work to be done that you forget that at the end of the day that the thing that you're making has to be used, probably, by a real live person. It's an important, it's an easy thing to forget about, but it can have wide-ranging effects. Sometimes the little challenges that we skip over in service of the big problems end up being way more important than we expect once real people are involved. There's a specific piece of history I use to remind myself of the importance of the small details and the effects of not thinking about the people who actually have to use what you make. So at the beginning of the 20th century, the science and practice of flying, of aircraft, was new and still very dangerous. The US Airmail Service, founded in 1918, had 31 of its first 40 pilots die in service. It's a 77% fatality rate. It took almost 30 years for the science of aircraft to start addressing that particular problem. Really. So the, crashing and burning like a plane here. What they found was that in World War II, a lot of the pilots, all the planes were better in World War II, they found that many of the planes were still crashing, and the phrase pilot error kept popping up. Now, the planes were new and the technology was still kind of scary, so the official story was that some crashes were to be expected. But psychologists working with the Air Force in 1947 stepped back and said something revolutionary. What if we talked to the pilots that were involved in these pilot error crashes? What if we found out what was happening? So that was the point where things really started changing and things started getting better. One particular example of how things improved was a problem that was studied in a specific series of military planes, B-17s. B-17s, for some reason, had an extremely high incidence of crashing during landings. So when a pilot is landing a plane, they engage flaps on the wings to help quickly reduce the speed of the aircraft. When pilots were landing B-17s, they would touch down on the tarmac, engage the flaps, and then accidentally retract the landing gear, causing the plane to shred itself on the tarmac as the wheels pulled back up. So the interviews with the psychologists found that the switch that controlled the landing gear was identical to and adjacent to the one that controlled the flaps. So in the delicate landing procedure, the pilots would, their attention was taxed, and they would hit the switch right next to the one they meant to use. This exemplified the underlying problem. There was a disturbing disconnect between the technology and the people who had to use it. Many of the planes that had pilot error crashes had these crazy missteps in their cockpits, where controls and levers that control identical things control different things would be beside each other, and gauges that showed critical information would be nestled in the middle of things that were not really very important at all. So retrofitting all of the, psychologists also found that nearly every pilot, no matter their level of experience, made mistakes, and the design of the cockpits was unforgiving. Instead of supporting the pilots and helping them recover from or prevent mistakes, the cockpits amplified the problems, turning small errors into potentially fatal crashes. So there was no way to retrofit all the B-17's cockpits. There was too many of them, they were too expensive. So a quick workaround was implemented. Small rubber things were mounted over the switches, a triangular one for the flaps and a round one for the wheels. Overnight, this problem disappeared. Planes that cost hundreds of thousands of dollars to build were being saved from an entire class of crashes by 3 cents worth of rubber. Now, most of us aren't building safety-critical things. If I mess up my design tomorrow, it's not going to cause a plane to fall out of the sky, I hope. But the things that we make still have to be used by real people, typically. So every time I see someone skipping testing of their design, I wonder what they're going to miss. What 3-cent piece of rubber is going to be overlooked? And is there anything more serious that could have been fixed? Taking a prototype, testing it, watching someone use it, and talking to them is going to tell you more about your design than almost anything else that you can do. The improvements that you get out of it will help make the jobs or lives of the people who use what you make easier. And that sense of pride that you get from watching someone use something that you've created will get stronger. It will remind you that the design that you make has to be in service of the people who use it. And that's so often it's the little things, the things that are so easy to overlook, that can make the biggest difference. Thank you.